Okay, good day. Today we will derive the governing equations for conservation of momentum. Okay, last time we derived the continuity equations for different models. Okay, so today we'll derive what we call the Navier-Stokes equations, or simply the conservation of momentum. Now, in order to derive this equation, we will use the model wherein you have a very small or infinitesimal fluid element that is moving along a streamline. Okay? So but also you can derive the continuous momentum equation using other models. Okay? But for this lecture, we will derive it using this model. Okay? So the conservation of momentum is from the Newton's second law, which states that or simply this is just the conservation of momentum, or the force is equal to mass times acceleration, or this is the change of momentum over time. Okay? Now, these forces, kaya nga forces, no, na nag-act sa imo ang fluid element is composed of body forces and surface force. Okay? So, mo ni ang nag-constitute ano yung force. No? Ang force ang experience yung fluid element. When we talk about the body forces, these are those under any is the force due to gravity. Okay? And also the electromagnetic forces. Okay? Now, body forces, these are forces that act directly on the fluid element. Okay? So, sometimes, dili kay dako ang effect aning body forces. Sometimes, ginagawa na siya. Gina-neglect. Ang main jud ng mga forces nga that will cause the motion of this fluid element, or that will affect, is kaning mga surface forces. Okay, so diri na lang. So, unsa ning mga surface forces? This is composed of the pressure and the viscous forces. Okay? Pressure forces, since ang imong fluid element is surrounded by fluids under pressure, no? So kung mo ni imong flow, okay, so the surface forces consist of the pressure forces and the viscous forces. Okay, ang pressure forces is caused by the pressure that is exerted to the fluid element by the fluid around it. Okay? So, kung mo na imong fluid element, ang fluid around it, nag-exert of forces, kaya ang boundary. Okay? Or sa iyang area. And then the viscous forces is composed of the normal and shear stresses. Okay? So, mga na siya. Okay, so ang ganing normal and shear stresses, the effect of the normal stress is kung mo na imong fluid element, so mag-act na sa normal or perpendicular sa imong area. Sample kani. So, ang effect ani niya, it will try to elongate or change the volume of the fluid element. In addition, ang imoang shear stresses, kung mo ni mong fluid element, ang shear stresses nimo mag-act na sa parallel sa imoang surface. No, so ang effect ani niya, it will try to deform the shape of the fluid element, no? So mao na siya. So kung i-combine nato na sa tanan nga effect, mo na gi-account ani nga forces. Okay? So that we can derive the momentum equation, let's have this notation. Okay? This one. Let's discuss first the notation. Okay? So kung mo ni ang imong fluid element, so ning enlarge, no, kung enlarge na to, okay, so imagine that you have this small fluid element and then ato siyang gi-enlarge, no? So mao ni karon kani. Enlarge na to, mo na ni siya. So unsay na dan? This is establish our coordinate system. This is the x, y, and z direction. Okay, so ang length sa imo ang element is dx, dy, and dz. Okay, now we will now account the forces that are acting on this fluid element. So sa ganito, you have the body forces and surface forces. Okay, so for the stresses, no, under sa surface forces, which are the normal and shear stresses, nag-act na sa mga surface. Okay? So imagine, kung mao ni ang imong fluid element, and then morning x direction, first we will derive the equation along x lang. So ang flow nimo is along x. So unsa ang areas nga maigo niya? So kani perpendicular sa flow, no? So dire unsa may experience na kay pressure forces. So kani ana denoted by P dy dz. Pressure times kaning area, no? P dy dz. So mo na dire, no? Pressure kay na may pressure tong fluid. Nga dire, and then so ang fluid nimo ana pass dire sa kilid ari ani sa lawom. So parallel. So maka-experience ni silang other phases, maka-experience of shear stresses. Okay? So pag agi sa imo ang fluid dere, malabay sa dere. So mao na yung forces niya. Again, ang force nga nag-act dere, opposite ani. Again, we can estimate using the Taylor series, no? So meaning P partial of P respect to x dx and then times area. Okay? Mao na siya. No, so nag-act na siya sa phase A, phase A, D, H, E. Kani. So mao na ang pressure forces. And then, sa palain, the shear stresses, no? Ang mga shear stresses. Okay. So, kung tanawin ninyo yung book, no? Anderson, figure 2.8. Nandito ang mga label. Okay? So, before na tumaplot ang shear stresses, we must ito sa ning studihan ang yung notation, no? Yung notation is denoted by tau ij. Tau ij. Ang kaning J is the direction of the stress, no? Ano direction of the stress. Huh? Okay, so this is the notation for our shear stresses. Okay, we have tau ij. Now, ang kaning j, this will determine the direction of the stress. Okay, ang kaning I is perpendicular aning ay dira makita ang plane kung asa ang shear stress nimo. Okay, so in other words, the I direction will determine kung asa ang imo ang okay, so na diri the perpendicular on the I axis. Okay, so perpendicular plane perpendicular to I dira makita ang imong shear stress. Okay, so para di mo malibaw, let's have an example. Tau xy. So aha man yung tau xy. Okay, mag-draw ta gamay nga box dere. Again, dere ang mga y, x, z. Tau xy. So asa ang y? So dere y. So paana ni? No, tau xy. Ang x dere no. So perpendicular ning x aha ang plane nga perpendicular sa x. So kaning duha mo na perpendicular sa imo ang x. So na dere, so paana ni sa karon? Ang direction, no? So ano yung reason, paana ni siya? Mo na tau xy. Okay? Tau xy. Opposite niya, diri sa pikas, naragay ko na diri. Opposite silang duha. Examples. So let's have another example, no? Okay. Tau yx. Tau yx. So x direction. So paana ni siya? No, x direction. Paana or paana. Na yun, y. So perpendicular sa y. So naa diri. Kani duha ka plane. Tapos po. So mag-ana ni sila. Paana ni karon. Paana. Dali pa sa pikas. Paana. Okay? Sabtan? Sabtan ba? Na, last example. Tau xx. Tau xx. So asa na siya sa x direction, so paana or paana. And then perpendicular sa x. Perpendicular sa x kani. Ni sila. Kani. So may tabuan na perpendicular na siya. Perpendicular na diri. So kung double mo na isa mga normal stress. Normal stress. Tau yy. Tau zz. Muna yung mga normal stress. Kung tau xy nga dili pareha tau xz, muna yung mga shear stresses. Okay? Okay, so going back, tanawin ninyo yung label ninyo sa imong book, no? So along x along x. The flow is along x. So say other forces ani naa kay normal, no? Normal. So ang normal so unsa ni siya? This is tau xx. No? Tau xx dy dz. Tama. Opposite niya diri pod. Ano pod? This is tau xx plus partial of tau xx. Right? X to x dx dy dz. Okay? Kumuha na sa forces diri sa side. Kani diri nga side. Mga shear stresses ni siya. Okay. May pass through raman ng kwanda. Parallel ang flow siya. So, saan yun na diri? You have tau yx no? You have tau yx. Ang direction sa tau yx. Muna ang tau yx. Diba? x direction perpendicular sa y. So tau y x area dx dz. So opposite diri sa taas na po ni ana tau pa niya po tau y x po tau y x partial of tau y x respect to x ano dx. Respect to y din. With respect to y. Respect to y. Tama, respect to y. Kay sa manang gi-estimate base sa value no? Base sa value diri. So, dy dx dz. Okay? Spelain. You have tau zx. Paharapin ng tau zx. Ang tau zx x direction then z. So diri nga side, no? So diri din na. Ana, maklaro pa ninyo. No? Tau zx. Diri po paano sa tau zx dx dy dx dy. Okay. Ani tau zx partial of tau zx respect to z dz dx dy. Okay? Okay, so na-label na nato tanan. No? Tanawan na rin yun yung book para mas maklaro. Therefore, ato na din na siyang i-sum up direct. No? Using summation of forces. Okay? Okay. Okay. Erase this one. So mo to ang surface forces to sa ang body force nimo. Body force is denoted by Fx or x only na no? X only. Ang unit ani niya is force per unit mass. Okay? Force per unit mass. Okay, ang surface forces nimo, surface forces, i-add na nato tong denoted by kani ito na i-denote ana no. I-add na nato tong mga forces kaya kanina. So you have pressure force P minus P plus partial of P with respect to X. Okay? dy dz plus tau xx no? Plus tau xx plus partial of tau xx respect to x dx. Minus nimo ang katong tau xx. Anyway, tanawan na rin niyo itong diagram. dy dz. Okay? Plus tau yx. Tau yx plus partial of tau yx respect to y. Tama ba? Respect to y dy minus tau yx dx dz plus tau x tau zx, right, plus partial of tau zx respect to z dz minus tau zx dx dy. Okay? May tabuan eh. Kani nga matter. Kani. Ang bilin ani, na lang, partial of negative partial of p respect to x plus tama, plus partial of tau xx x plus partial of tau yx respect to y plus partial of tau zx respect to z dx dy dz. Okay? Ano yung total sa surface forces? Okay. So, kung i-add natin yung body force of surface force, i-add na ito na i-reason. By the way, ang gantong mo ang body forces, diba, f of x naman to, no? Multiplyan mo ni kay force per mass man eh. Multiplyan mo ni karon o mass. Ayan, multiplyan mo mass. So may ang forces ni mo ni body force is rho dv, rho dv fx. This is rho dx dy dz fx. Okay? Tumora na siya. So, ding i-add garon. I-add na to total force in x direction. Total force in x direction is just sum sa body force of surface force. Plus okay. Plus body forces. Body force is rho f of x. Okay. Okay. So na define. We have already defined this parameter. So next na itong i-define is kani. mass and acceleration. Okay, so ang imong acceleration nimo is just change in velocity. So ang velocity nimo along x is u man. So oron na siya. Acceleration x nimo. Acceleration in the x direction. Okay, ang imong mass, kaning mass nimo, ang mass nimo is just rho dx dy dz. Okay, so ato ning aning nga term, ato ning i-equate aning MA, so ato na nung ning i-reson. May mo na rin ning rho dx dy dz du over dt. Okay? So, cancel na ning. Ano sa mabilin? Bilin is you have rho du dt is equal to negative partial of p d partial x plus partial of tau xx plus partial of tau yx plus partial of tau zx respect to z plus rho fx. Okay. So this is now your x component of momentum equation. Okay, so x component pa lang ni of the momentum equation. So we'll also derive the y and z. So the same process ang 4y kung sa mga tabo wala analogous ra ani so negative partial of p na v mo ni ang velocity along y plus partial of tau xy plus partial of tau yy partial of y plus partial of tau zy partial of z plus rho fy. Okay? Lastly, for the z direction, no, z component, you have rho dw dt negative partial of p partial of z plus partial of tau xz respect to x partial of tau yz respect to y plus tau zz plus rho fz. Okay? So mo ni kanis lang nga tulo ka equation mo ni gitawag nga non-conservation form. No? Non-conservation form. And then kaning tulo mo ni sa ang Navier-Stokes equation. Navier-Stokes equation. But later on, no, since non-conservation form man pwede nyo na siya ma-convert into conservation form. So, saan man. Convert nyo sa conservation form. Okay? Gamito na to ning sa x. Rho du dt negative partial of p partial of x partial of tau xx partial of tau yx plus partial of tau zx plus rho fx. Okay? So gamito na to nino. So kani itong pangitaan na to ni siya og value unsa ni siya. So, based sa meaning sa substantial derivative, ang du over dt equal ni siya sa namin ni rho, no? Rho partial of u partial of t plus rho v, rho v del u. Okay? Equivalent na sila. No? Naman eh. Ano nga definition na dito sa book? So, sa later nga, previous na ito ang i-discuss. Therefore, kung ato ning kuha ng partial sa okay? Therefore, ano nga term? Rho partial of u partial of rho u minus u. Okay? Kana. So, kani nga term na mo ni. Kani mo ni value. So, pangitaan po nato ni kung sa value ani. Ang value ana anyway, i-verify na lang ninyo ni. Naman ni sa book. U dot rho b rho u b del rho u b equal to u del dot rho b plus rho b dot del u. Okay? Now, kaning v mo na ang velocity. Ang value sa v, no? Kaning v. V is just ui vj. Mora na siya. Vector man eh. Mora na siya. So, ito ning ipagawas kani kay mo man ipakita na to. Minus u del okay? Therefore, ato na din ning kani ato ning substitute dia kani dire. Okay? So sa metabo na. Substitute na to. Mahimo na lang ning rho du dt is just equal to ang value ani, partial of rho u partial of t minus u partial of p ddp partial of rho minus u del dot rho b plus del dot rho ub. Okay. Muna siya. No? So, collect na to ni minus u partial of rho partial of t plus del dot rho b plus del dot rho u b. Okay? Ang sa metabo nila. Kani nga term, take note, kani nga term, morning continuity equation, no? And kitong na-derive na to, this is equivalent to 0 kani nga term. So, mahitabo nga rho du dt is just partial of rho u partial of t plus del dot rho u b. So, mo din yung value ani. Mo din yung value. Ito din yung i-plug in dari. Okay? So, i-plug in na. Plug in diha. Ayun mo na dahil yung partial of rho u partial of t plus del dot rho u b negative partial of p partial of x okay. So, mauna na siya. No? For the y and z, may mara ko ni partial of rho v nga gamay, partial of t, plus del rho b, negative partial of p, partial of y, partial of tau xy, partial of tau yy, plus partial of tau zy. Okay. Ngayon, partial of rho w plus del dot rho w b negative partial of p partial of z plus tau xz plus partial of tau zz plus rho fz. Okay, so ano ni ang conservation form. These are the conservation form sa Navier-Stokes equation. Okay? But, pa yung mga kulang na term kani, wala pa man na-define. Ano sila? No? Okay, so we have derived the conservation form of the Navier-Stokes equation. So this is for the x direction, momentum along x, along y, and along z. Now, as I have said, we still need to define the mga shear stresses, mga components, no? Normal stress and shear stresses. Okay? So, Stokes derive the values for this using the Newtonian fluid, no, assumption. Newtonian fluid meaning ang shear rate or ang change sa velocity, no, is linear, no, linear compare sa ang shear stresses. So according to him, no, iya man gi-derive taas kay derivation so just familiarize value. So ang tau xx, this is, by the way, again kaning same ang kuan nga indices mo ni ang mga normal stresses. So equivalent aning lambda del dot v plus 2 mu partial of u with respect to x. Ang lambda take note ang lambda, this is just equal to negative 2/3 mu. Okay? Negative, lambda is negative 2/3 mu, or the second viscosity coefficient. Okay? So, i-plug in lang nimo na sila mga values. And again, kaning tau xy is just equal to tau yx plus mu partial of v partial of x plus partial of u over y. Okay? Okay. So, mahimo na lang ni siyang ani, no? Plug in mo to kaning mga value ani. Kaning mga value plug in mo dire. Rather, plug in mo dire ani. Sa isa. So, mo na dahil ni. Okay? Mo na dahil ni ang Navier-Stokes equation. Okay, so just familiarize, no? Derive ninyo ang kaning equation para ma-familiarize ninyo.